All right, so this is a 3-point problem. So the first step on it is just see which, so this is where we have a geological contact at depth in drill holes. So the contact is at 25 meters here, it's at 75 meters here, and 100 meters here. So what we do first is just go from the highest and lowest, and what we want to do is draw a line between them. So this is the line between the lowest and highest, and what we have to figure out is where along this line we hit 75 meters. So I can do that by measuring, and then that's a little mark at 15. So the total is 17.7 centimeters. Now the distance between these is 50, 75. So we basically just have to divide 17.7 by 3. We'll just call that 18 centimeters. So it's going to be 6 centimeters minus a millimeter. So 5.9 centimeters is the distance along this line to split it up into 25-meter increments in terms of elevation. So 5.9. So this is 75 meters, and we could put it in again, another 5.9 from that side, and then that would be where 50 meters is. Now what we do is we have an area where 75 meters is equal to 75 meters. We can connect those dots, and with the top of the page being north, we now can tell the strike, because the strike is the distance where there's 0 dip. If we have the contact at the same elevation in 2 places, there has to be 0 dip between them. So all we do is measure the strike now off with this line. So 10, 20, 30, 34. So that is 34 degrees for the strike. Now the next thing is to determine the dip of the bed. So it is going from 75. So what we have to do is figure out where we are perpendicular to the strike. So extend that line perpendicular, so 90 degrees to the strike. We will connect that 75-degree line up to 100 meters. And we want to find the triangle where we have a drop from 75 to 100. So it's 25 meters there. And now we need to figure out what this distance is here. So for this, we need to use our scale, and 3.1 centimeters is equal to 100 meters. And then we can measure off of here, 5.3 centimeters is equal to X meters. So this can be set up as X meters is equal to 100 meters over 3.1 centimeters times 5.3 centimeters. The centimeters cancel, and we just have to do that math. All right, and then we can solve for this. X is equal to 171 meters. So we can put that here, 171 meters. Now we have to set up the tan equation. So tan of the dip is opposite over adjacent. So tan theta is equal to the opposite, which is 25 over 171. So theta is equal to arc tan 25 over 171. And that is equal to 8.3 degrees. So our strike is 0.34 and it's dipping 8.3. Now just one thing for clarity, because these are drill holes, they're going down. So that is why we know that it's dipping in this direction, because we're going from 75 and we're going 25 deeper. So right hand rule, strike this way, and it's dipping that way. If these were elevations, we would have to think the other way around, and if this was higher than this one, it would be dipping in the opposite direction.